Hello everyone, in this video we will be learning about the trigonometry quadrant. In front of you here is the 4-quadrant system and we will be numbering the quadrants in an anti-clockwise fashion. So starting with this one, which is the first quadrant, second, third and the fourth. So in this quadrant system, we will be mainly dealing with 5 angles: 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. So before we move on, let us discuss about odd angles and even angles. Now for this concept, out of the 5 angles, we will be considering 90 degree, 180 degree, 270 degree and 360 degree. Now, we know that the odd numbers are 1, 3, 5, etc. So, in this kind of classification of odd angles and even angles, we are going to be considering the first 2 digits in the case of these 3 angles and this the first digit in the case of this angle. As we know, 9 is an odd number, then 90 degree will become an odd angle. 18 is an even number, so 180 will be an even angle. Similarly, 27, as you know, is an odd number, so 270 degree will become an odd angle. 36, an even number, so 360 degree will become an even angle. So the odd angles will be 90 degree and 270 degree, and the even angles are 180 degree and 360 degree. These are few basic facts that you need to keep in mind in order to solve trigonometry based sums. Now, what is the importance of odd angles and even angles? So, whenever you have to deal with odd angles, the trigonometry function changes from one to another. For example, sine changes to cos and cos changes to sine. Similarly, tan changes to cot and cot changes to tan. Cosecant changes to secant and secant changes to cosecant. So this happens whenever we get an odd angle. So this is an important conversion which we need to remember. Now let's move forward with the table. By the look of this quadrant system, we see that each quadrant is 90 degree. So these 5 angles are going to be represented in this quadrant system as follows. First quadrant ranges from 0 degree to 90 degree. The second quadrant ranges from 90 degree to 180 degree. The third quadrant from 180 degree to 270 degree. And the last quadrant from 270 degree to 360 degree. In terms of radians, this is going to be from 0 radian to pi by 2 radian, from pi by 2 radian to pi radians, from pi radian to 3 pi by 2 radian, and from 3 pi by 2 radian to 2 pi radian. So this is going to be the general representation of the coordinate system. Again repeating, 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. The next thing we are going to learn is what are the angles that lie in each of these quadrants. Again, this is a basic rule and you need to learn it that way. So the first quadrant, the values which lie are 90 minus theta. The second quadrant, 180 minus theta, as well as 90 plus theta. The third quadrant, it is 270 minus theta and 180 plus theta. The fourth quadrant, 360 minus theta and 270 plus theta. Again, coming back to the first quadrant, we already had 90 minus theta. Now it is 360 plus theta. By now, I assume that you would have found the general trend. That is, we start with the minus theta of that particular quadrant. Here the highest number is 90 degree minus theta. Second quadrant, 180 minus theta. Similarly, third, 270 minus theta. And the fourth, 360 minus theta. And if you're talking about plus theta terms, it is gonna be the lower range. Starting from second quadrant, which will be 90 degree plus theta. The third quadrant, 180 plus theta. And the fourth quadrant, 270 plus theta. Even though here 360 is not the lower degree, still the first quadrant will have 360 plus theta. It will take some time to remember these, but once you have learned this thoroughly, the calculation part becomes really easy. Now, after we have all these foundations laid, let us talk about the ASTC rule. Now, the ASTC rule, 4 letters stand for each quadrant. A standing for all, S standing for sine, T standing for tangent, and C standing for cosine. So according to this rule, in the first quadrant, all the values, all the trigonometric functions are going to be positive. In the second, sine term is going to be positive, as well as the reciprocal of sine, which is cosecant, will be positive. In the third quadrant, tan is going to be positive, and the reciprocal of tan, which is cot, it is also going to be positive. And in the fourth quadrant, cosine and the reciprocal of cosine, which is secant, is gonna be positive. Again, ASTC stands for all, sine, tan, and cosine. After you remember these 4 letters, in the second, third, and fourth quadrant, along with the reciprocals. So for sine will be cosecant, tan will be cot, and for cosine it will be secant. So just a quick summary of the things that you need to learn before solving the sums based on the ASTC rule. First one being, what are the different angles in each of the quadrant? The second one, what ASTC stands for, and what are the different functions which are positive in each quadrant. And the third one, the difference between odd angles and even angles. Now let's solve few of the sums. So the questions based on this topic are from exercise 3.2 from the class 11 NCERT textbook, along with few examples starting from example 6. So let's try solving the example 6. So the question says cos x is equal to minus 3 by 5, and it tells that x lies in the third quadrant. Given these two data, it's asking us to find the values of all the other 5 trigonometric functions in the third quadrant. Now, according to the ASTC rule, we know that this stands for the third quadrant, and in the third quadrant only tan and cot is gonna be positive. The rest of the trigonometric functions are gonna be negative. So the first step in solving this sum is to use the triangle method and solve the other functions. So cos, we know that it is adjacent by hypotenuse, so this side is gonna be 4. From this diagram, we know that sine x opposite by hypotenuse 4 by 5, cos x already given, cosecant x is going to be the reciprocal of that, which is 5 by 4. Tan x is going to be opposite by adjacent, which is 4 by 3. And cot x is going to be the reciprocal of tan, which is nothing but 3 by 4. Similarly, the last function, which is secant x, is going to be the reciprocal of cos, which is 5 by 3. Since cos is given in the question, we can directly write secant x as minus 5 by 3. The reciprocal is directly minus 5 by 3. Now, according to the ASTC rule, as already stated, in the third quadrant, only tan and cot terms are going to be positive. So what you're simply going to do now is add a negative sign to the rest of the terms, which implies that in the third quadrant, sine is negative, cosecant is negative, secant is negative, as well as cos is negative. So simply going through the steps again, in such kind of problems, using the triangle method, first find the different functions without any sign, just find the values and write it. Then using the acronym ASTC, find out which trigonometric functions are going to be positive in that particular quadrant. Here is tan, so tan and cot will remain positive. All the other trigonometric functions will get a minus sign. Now, in order to type sum such as cos of minus 60 degree or cosecant of minus 720, etc., there's another concept we learned called as even functions and odd functions. So the general form of this topic is that if f of minus x is equal to f of x, such trigonometric functions are said to be even functions. Similarly, if f of minus x is equal to minus f of x, such functions are said to be odd functions. So this concept again is derived from the ASTC rule, according to which in the fourth quadrant only cos and secant, these two functions are positive. So cos of minus x, the expanded form of this is nothing but cos of 360 minus x, which lies in the fourth quadrant. Since cos is positive, the answer simply comes out to be cos x. It's not only 360 in the fourth quadrant, we can take it as n into 2 pi. 2 pi stands for 360 and any integral value. If it's 1, we get 360. 2, we get 720 degree, etc. So the same rule applies for any other function which can be written in terms of multiples of 360. So similarly, secant of minus x is secant x. However, all the other terms are going to be odd functions. Sine of minus x is going to be minus sine x. Tan of minus x is going to be minus tan x. Similarly, cosecant of minus x is going to be minus cosecant x. cot of minus x is going to be minus cot x. The calculations based on this type will be uploaded in the next video shortly. Thank you for watching this video, and if you enjoyed, please give it a like and subscribe if you haven't already.